the next program. Write a program to calculate the sum of all diagonal elements in a matrix. If there is a common element, it should be considered only once. So in this program, I'm required to calculate the sum of the diagonal elements. And if there is a common element, it should be considered only once. Now let's first understand what are diagonal elements. Now look at this matrix. I've drawn a couple of matrices over here. Now observe this. Over here, some of the diagonal elements. So when you talk of a diagonal, I'm basically looking at these values, right? So I need 6 plus 12 plus 9. And then the other diagonal. See, though mathematics, they don't call it as a diagonal, but in coding, this is what is needed, 9. So 6 plus 12 plus 9 plus 5. And then this 5. Now understand, this value 12 is common to both the diagonals, so it should not be added twice. Don't be under the impression that 5 appears here and 5 appears here, so I'll not add 5 twice. No, you will add 5 twice. It's just that this value 12, which is common to both the diagonals, it should be considered only once. Now, look at this. Look at the second matrix. Now, this is a matrix of order 2 by 2. So my first diagonal is this. So it is 6 plus 12. And then you have this is my other diagonal. So my next two values are 2 and 13. So this is the expected answer. So in this matrix, you can find that if I talk of both the diagonals, there's a common value which should be added only once. Then there is a matrix which does not have a common value, right? So I have to get the sum of the diagonal elements. And if at all there is a common value, it should be considered only once. I hope the question is understood. Now, one very, very, very important point with reference to this program is, now look at this. This matrix that I'm talking about over here is a 3 by 3 matrix. We call this as a square matrix, where the number of rows is the same as the number of columns. This is a 2 by 2 matrix. This is again a square matrix. But look at this matrix. This matrix has 3 rows and 2 columns. This is a 3 by 2 matrix. Now, if you see, for a non-square matrix, the diagonals do not exist. So in this program, if you give me a matrix like this, and if you ask me to calculate the sum of the diagonal elements, it's not possible only because diagonals do not exist for a square, diagonals do not exist for a non-square matrix. So what I conclude out of this is that this program has to run strictly for a square matrix only. Now, if you read the question says, write a program to calculate the sum of all the diagonal elements in a matrix. If there is a common element, it should be considered only once. Nowhere they've mentioned that the program should work only for a square matrix. Now, that is something which we have to understand for ourselves, that the program needs to work with diagonal elements. And talking of diagonal elements, it has to be a square matrix. So now I'm going to make some change to my program so that this program will work only for a square matrix. Now observe this. How can I convert my program in such a manner that it works only for a square matrix? Observe. See, so far in our programs, we were asking the user the value of n and the value of value of m and the value of n. Suppose if the value of m was 3 and n was 2, so it becomes a matrix of order 3 by 2 because it's a matrix of order m by n. See, if I'm reading two values from the user, it is always possible that user might give me two different values and then it becomes a matrix of order m by n, right? So one strategy that I can adopt is I'm not going to read two values from the user. I'm going to read only one value, say n. Suppose if you give me the value of n as 3, what I'll do is I'll use the same value of n twice. So it becomes a matrix of order 3 by 3. If I don't read two different values from you, तो आपको जब दो values ही नहीं दे पाओगे, तो आप non-square matrix बनाओगे किधर से? That is why we will be using something like this. I hope this is understood. Okay? Now, just observe this. How is this program going to work? I'll change my program. Suddenly you will see from my entire code, this m will disappear. The reason why m is disappearing is, for me, it's a square matrix and it's of the order n by n. So how do we do this? Observe this. I've started here. I've started by declaring some variables. I've created this matrix as always. If you see, I've declared only n. There is no m over here, right? Now what I've done is, say I've declared this function. enter value. Suppose the value you've given me for n is 3. Now I'm not reading the value of n. So over here, the number of rows are also 3 and the number of columns are also 3. Now, you have to look at it as a matrix of order n by n. So number of rows is also 3 and number of columns is also 3. Now, reading a matrix, I'll go row, column, I, j. Now in this program, the number of rows is also n and the number of columns is also n. So what have I done? For I is equal to 0, I less than n, row, j is equal to 0, j less than n, column, both are n, and I, j. If you see from this part of my code, m has totally disappeared. Everything is just n. So I've read this matrix, say A of order n by n. Then I'm calling this compute function. I'm passing this value A, which is the matrix. And in the previous code you had seen, I had passed both M and N. M does not exist for this program. So I'll pass only N. So I hope it is understood why M has disappeared from this main function, because now I have ensured that this program will work only for a square matrix of order n by n. Now in my example, I have taken a matrix of order 3 by 3 and then we'll execute it accordingly. Now here comes my function for calculating the sum of the diagonal elements. Now don't bother looking at the code. I told you right at the beginning, if you just observe the indexes carefully now, you will automatically get your answer. Now let me just try and understand. I want to get the sum of the elements on the leading diagonal. Let me just mark out the leading diagonal. Now observe. Now in my program, you see what we are doing is variable I is always giving us the row numbers and variable j is always giving us the column numbers. Now look at this first value 6. Uska index is 0, 0. Iska index is 1, 1. And this value 9, the index is 2, 2. Can I say for any given value, if the row number I is the same as the row number j, then the value falls on the leading diagonal? If you see, that is not the case with any other value. So how do I identify whether a value is on the leading diagonal? If the value is present at an index where the row number is the same as the column number, or you can say the value of I is the same as j, then the value is on the leading diagonal. So later on what I'm going to do is, I'm going to visit all the values. I'll check कि बाबा ये value leading diagonal पे है क्या? If yes, add. If no, leave it. But how do I identify? By looking at the indexes. See how obvious it was if you look at indexes, how to identify leading diagonals. Now talking of the other diagonal, now let me talk about, say, the values on this diagonal, this one, and this one. See, this is a matrix of order n by n. So n is 3 over here. Now look at this. Look at these indexes. 0 plus 2 is 2. Look at this. 1 plus 1 is 2. And look at this. 2 plus 0 is also 2. Can I say that if I add the value of I, which is a row number, with the value at j, I'm getting, if n is 3, this is n minus 1 now. Now look at this again. If row number, if the first value is the row number and second value is the column number, first value is I, second value is j. 0 plus 2 is 2. 1 plus 1 is 2. 2 plus 0 is 2. So what I found is on the other diagonal, whenever I add the values of I and j, I get it as n minus 1, where n is the number of where n is the order of the matrix. So can I say that if for a value, if I same as j, matlab the value is on the leading diagonal? If I plus j is equal to n minus 1, that means the value is on the other diagonal. So these are the two conditions. So how exactly is my program going to go from here on? Now what I'm going to do is, I'm going to visit all the memory locations over here. I'll check both the conditions. I'll visit all the memory locations. I'll execute the loop for you, not to worry. I'll check both these conditions. If this condition is true or this condition is true. I hope now you understand कि ये दो conditions किधर से आई. If both these conditions are true, then if either of these conditions are true, then you add the value. When will this condition be true? When the value is on the leading diagonal. When will this condition be true? When the value is on the other diagonal. So wherever these conditions are true, one of these conditions is true, I'll go ahead and I'll execute, I'll add that value. Also, now this operator that you have is a logical OR operator. What's a logical OR operator? I have two conditions over here. Even if one of the conditions is true, it will go ahead and execute the statement. Is this understood? It's a logical OR operator. Now with this matrix that you see in front of your screen, on your screen, I'll execute this example. I'll execute for a couple of values at least. Now observe this. N is 3. So number of rows is 3. Number of columns is again 3. So how do we proceed from here? Observe this. Okay. Now, when I start here, this is I0. 0 less than 3 is true. Come down. J0. 0 less than 3 is true. Now I'm checking. I is 0 and J0. 0 is equal to 0 is true. Now, why has this happened? This has happened because this has happened because the value is on the leading diagonal. So I'm checking the first value, and then I plus j, 0 plus 0 is 0 and n minus 1 is 2. So my second condition is false, but because the first condition is true, I'll add this value. The new value of sum is the existing value of sum, which is initialized to 0 plus a of ij, I0, J0, A0, 0. What is the value at A0, 0? Which is 6. So basically, I checked the first value. I realized that it's on the leading diagonal, and that is why I have added that value. Okay. Now, once this is done, I go over here. J plus plus is 1 now. J is 1. 1 less than 3 is true. Now, look at this particular step. What's happening on this step? Now again, I'll have to check both the conditions. If wherever the condition is true, if at all the condition is true, I'll add that particular value. I'll start here. Now I is 0, J is 1. See, basically I'm now testing this value, right? So 0 is equal to 1 is false. I 0, J is 1. 0 plus 1 is 1. 1 is equal to 2 is false. Both the conditions are false. See, for a value which does not fall on any of the diagonals, both these conditions will go false. Now that both the conditions are false, I'll go back. J plus plus is now 2. Come this side. So J is now 2. Now I'll go ahead. I is 0 and J is 2. Now I'm going to test the next value. Now observe this. How will the next value work here? Okay. Now I is 0 and J is 2. 0 is equal to 2 is false. This first condition is false. 0 plus 2 is 2. 2 is equal to 2 is true. This is true because the value is on the other diagonal. If this is true, come down. The new value of sum is the existing value of sum plus a of ij. I0 and j is 2. A0 2 mein kya value hai? 5. So if you see, this value got added and this value got added. Then I'll go back. J plus plus will become 3. This loop will fail. Then I'll go back. I will change, and this is how I'll keep checking all the memory locations. If you see, this is nothing but row column ij. I'm checking all the memory locations, and wherever either of the conditions is true, I'll add that value. Now, for this particular value, see, observe. See, there's a case that is mentioned that the common value should not be added twice. So what happens is, see, when we'll test this value, na, over here, I ka value would be 1 and J ka value will also be 1. So 1 is equal to 1 will be true, and 1 plus 1 is equal to 2 and n minus 1 is also 2. Both the conditions will become true at the same time, and then the value will get added over here. So it any which ways will not happen that the value is getting added twice. Over here, the value will get added once only, but both the conditions will become true at the same time, and that is the only possible case where this is going to happen. In all other cases, you will find that either of the conditions are true. So this is how you'll calculate the sum of the diagonal elements. This is one question which appears a lot of times in the examination papers, right? Over here, will deal only with square matrices by reading a matrix of order n by n, and then this is how you are going to get the sum of the diagonal elements. Now suppose if somebody says that, okay, I don't want you to use the Now here is the next question. Write a program to generate the transpose of a given matrix of order n by n. Now over here, when you say transpose of a matrix of order n by n, matlab I need to generate transpose of a matrix or transpose of a square matrix where the number of rows is the same as number of columns. The same question can be asked as write a program to generate the transpose of a given matrix using the method of swapping, and a program to generate the transpose of a matrix without using an additional array. Now, what is the significance of this? I'll discuss this with my next question. As of now, let's keep things simple. What is the program all about? In this program, I'm required to generate the transpose of a matrix of order n by n. Now, how do we go about doing this? Please observe this. Now, for all those who don't remember what transpose is, now this is what the transpose is. If suppose this is my matrix A with these rows, I need to interchange the rows and the columns. So 6, 2, 5, whatever is the row over here will become the first column over here. Then the second row that you have over here will become the second column over here. So transpose is precisely when we interchange the rows and the columns. Okay? So that is what is the aim. Now let us first quickly try and figure out how exactly are we going to get the transpose. Now just look at the logics carefully. You just understand this. Suppose this is my input and this is my expected output. Just by looking at the indexes, you will be able to understand what has to be done. Now observe this. Now this is my original matrix. Now in this matrix, observe. And I'm just comparing the values. Whatever is the value, say at index 0, 0 over here, it is at index 0, 0 here. Whatever is the value at index 0, 1 over here goes to 1, 0 here. Whatever is the value at 0, 2 here, it goes to 2, 0 here. Whatever is the value at 1, 0 over here goes to 0, 1 over here, and so on. So what I understand is, see, if you look at both the matrices carefully, the value at index 0, 1 in the original data is at 1, 0 in the transpose. The value at index 0, 2 in the original data is at 2, 0 in the transpose, right? Can I say if I is the row number and j is the row and the column number, in that case, whatever is the value at index ij in the original matrix, that value has to go to index ji in the transpose. If you see, the value at index ij in the original matrix will be passed on to ji in the transpose. So that is what is the aim. Now, if nothing was mentioned, I could have easily done something like this. Understand? I would have created a matrix A. Then I would have created another array called B. Then what I would have done is, I would have picked up all the values. Now I is always giving you the row numbers and j is always giving you the column numbers. So in this matrix A, I'll go to index ij 0, 0 and copy it to 0, 0. Then I'll go to 0, 1, whatever is the value, I'll copy it to 1, 0. I'll go to 0, 2 and copy it to 2, 0. So what I would have done was, I would have just created two arrays. Whatever is the value at index ij in A, I would have copied it to ji in B, and then I would have got my final answer. So it would have been a pretty straightforward question. But to stop me from using the easier option, I've been told, do not use an additional array. So what I understand is, if this is array A, I'm not supposed to create another array. So whatever has to be done within this array itself. So now I'm thinking, now that I'm not allowed to use any additional memory, what do I do? Observe, just look at this carefully. See, if you compare this value, see this value 2 has to 0, 1 ka value has to go to 1, 0, and 1 0 ka value has to go to 0 1. So precisely what I need to do is I need to swap these two. I need to swap the value at 0 1 with the value at 1 0. So if I swap these two, if I exchange 0 1 and 1 0 ka value, if I exchange 2 0 and 0 2 ka value, and if I exchange 2 1 and 1 2 ka value, I'll get my transpose na. So all I need to do is I need to take the value at ij in index array A and swap it. Swap is exchange it with the value at index ji in A itself. So what is the method of swapping? What I understood is the relation between the original matrix and the transpose is that whatever is the value at index ij in the original matrix, it gets copied to index ji in the transpose. So what are we planning to do? We are planning to write the code which will swap the value at ij with the value at ji. So that is what is the plan for us. I hope this is understood. Okay. Now I'm going to write a loop in which I'm going to read a square matrix, which is obviously of the order n by n. And then I'm going to swap the value at ij with the value at ji. I hope ये समझ में आ गया. अच्छा, whenever I want to swap these two values, मैं क्या करूंगा? एक extra variable लेके आऊंगा पहले temp. ये 2 को इधर copy कर लिया. Then this 13 will go here, overwrite this. और यहां से this 2 comes in over here to override this. You will always use an extra variable for swapping the values. Now observe this. How do we go about writing this program? Now in this program, again, I've started by creating a matrix. I'm again using only n because it is a program for square matrix, right? Okay, so I've read the value of n. Suppose you've given me the value of n as 2. So you want me to work with a 2 by 2 matrix. I'll read the matrix row, column, ij. So row is also n, column is also n, a of ij. So I have read this matrix of order 2 by 2. Then what I do is I pass this matrix to a function. So far what we've done is we've created this matrix and we've passed this matrix to a function called compute, which is now going to generate the transpose. Now observe this. Coming to this function. Now just observe this. I'll first help you out with the logic. Then we'll try and execute this. We will find that there is some little problem with this particular code, and then we'll go ahead and try and solve this problem. Now just look at this very carefully. So I'll just make some space here. Okay. Now over here, I've got this matrix which is of the order 2 by 2. The value of n is 2. The value of n is 2. Now, if that is the case, in that case, how exactly does this work? Observe, I'm going to write a loop. I'm going to go row, column, ij. I'm going to pick up all the values from over here and swap the value at ij with the value at ji. I'm going to swap the values at index ij with the values at index ji. Now let us see what happens. See, by the look of it, it appears fine. Everything looks fine. Okay, what am I doing? I'm swapping the value at ij with the value at ji. But then understand what happens. Why is this code incorrect? We'll first figure that out and then we'll talk about what is the current solution. Now observe this. I'm swapping this values at ij with the value at gi. Observe. For I is equal to 0, n is 2. 0 less than 2 is true. Come down. J is equal to 0, n is 2. 0 less than 2 is true. Come down. As of now, I and j both are 0. So 0, 0. A 0, 0 ka value goes to temp. In this array A, the value at A 0, 0 is 6. See, I and j are both 0. I'll make some space here as well. Maybe I'll be able to write better. Okay. Now, okay. So 0, 0 ka value has, or let me just start this again. I 0, 0 less than 2 is true. J 0, 0 less than 2 is true. Come down. Take the value at A 0, 0. The value at A 0, 0 in this array is 6. As of now, I0, J0. So this is A00 gets copied to A00. Basically, C gets copied, 6 gets copied here itself, right? And then temp ka value 6 goes to A00. So what has happened is in the first step, the value got at 6 got the value 6 got swapped with itself. The reason is in the transpose, this value 6 has to stay where it is, where the value is currently. So it did not change its position. Then I go back, J++ is 1, 1 less than 2 is true. Come down. Now coming down over here, what I find is I ka value hasn't changed. The only value that is going to change now is my J ka value. So let's see what happens over here. So coming over here, the new value of J is 1. So this is 0, 1. A01 ka value kya hai? 2. That has gone to temp. J is now 1. Now observe this. Now look at this statement. A10 ka value will get copied to A01. A10 ka value is what? 13. It gets copied here. So 13 has overwritten this 2. And then temp ka jo abhi value tha 2, that will go to A10. So वो 2 इधर आ गया. So हमने क्या किया? पहले 2 को temp में रखा, then 10 का value 01 पे copy किया और temp से 10 में copy किया. So this is how I've swapped the values, right? Now when I go back, J++ will now become 2, right? 2 less than 2 is false. Condition fails. You go back. I++ is now 1. 1 less than 2 is true. And now the loop starts again. Now observe what happens here. Okay. So this loop will restart now with the new value of I. So I'll just erase this out quickly. Okay. Now I is 1, 1 less than 2 is true. Come down. J0, N is 2. 0 less than 2 is true. Come down. As of now, I is 1, J is 0. 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 So A10 ka value goes to temp. A10 ka value kya hai? 2. That goes to temp. A01 ka value goes to A10. A01 mein kya hai? 13. It comes here. And temp ka value goes to A01. Temp ka value was 2. Now, if you see what has happened is, I wanted to swap the value at ij with ji. Now that has happened, but the problem now is, if you see, whatever swap I had made, that has been negated. Na? See, understand kya hua? In the previous step, when I was executing this, to hua ye ki ye 2 idhar se idhar aaya, and this 13 went here. Then later on, when my program continues, when I swap for the second time, this 2 again is replaced by 13, and this 13 is again replaced by 2. So it's not that the values are not being swapped, but the problem is that the values are getting swapped twice. So I need to ensure that the values do not get swapped the second time. Now also understand, why is it that these values are getting swapped twice? Why did it happen that I'll get the value swapped twice? See, kya hua? Pehle na humne isko ij pakda 0, 1 ko, and then swap the values. Now as my program went ahead, I'll take this as ij and then swap this again. So every value actually got swapped twice, and that is where this program, if you write whatever I've just written over here, whatever is the input you give me, you'll get exactly the same same output. The reason is every value is getting swapped. So what I'm trying to do is fine. I'm trying to swap the value at ij with the value at ji, just that I want to prevent the values from getting swapped the second time. That is why I'm going to make one little change to this condition. What? Instead of starting with j as 0, I'll start with j as I+1. Rest entire code remains the same. Now by doing this, what will happen is the system will make sure that this values are not swapped the second time. So when I take this 2 will override this 13. This 13 will override this 2, and then they'll not get re-swapped again, and then my transpose will be generated. Most students, when they attempt this program, this is where they make a mistake. If I start with j is equal to I, though rest of my program is correct, my output will be absolutely incorrect because the values will get swapped twice. So this will generate the transpose using the method of swapping. Now finally, once all is done, I need to display the matrix. I've got the transpose. I just need to display the matrix. How do we display? Row, column, I, J. The same loop. See, when it comes to displaying the matrix, the loops never change. For I is equal to 0, I less than n, row, column, printf A of I, J. So this will generate the transpose. So what have we done? We've read the matrix over here, right? We've read this matrix over here. We've passed it to the compute function. Compute function has calculated the transpose, and then calculate function has, compute function has also displayed the final result. So that is the program for generating the transpose of a square matrix. Now, let's go to a more general program. Write a program to generate the transpose of a given matrix of order m by n. So previous program was that I'm required to generate the transpose of a square matrix. Now this program is how to generate the transpose of any given matrix. It could be of any order, not necessarily square matrix. In that case, how do I generate the transpose? Now please observe this. Now let's first understand the funda. Now look at this matrix. Suppose if I have this matrix A, right, which is of the order say 2 by 3. And this is the transpose. On the right hand side, you can see the transpose of that matrix, right? Now suppose I'm thinking, okay, let me just try and correlate. See, the value at index 0, 0 is at 0, 0 in the transpose. The value at index 0, 1, which is 2, goes to 1, 0. The value at 0, 2 in the original matrix goes to 2, 0 in the transpose. The value at 1, 0 in the original matrix goes to 0, 1 in the transpose, and so on. So basically what I again understood is from the original matrix, if I want to go to the transpose, whatever is the value at index ij, it has to go to index ji. That is okay. Now again, observe this. I'm thinking, let me just use say the method of swapping. The method that we just saw. In that method, what we did was we were just swapping the value at index ij with the value at index ji. Now, if I try to understand the same funda, if I try to apply the same funda, in this matrix, if I want to swap the value at 0, 1, I'll swap it with the value at 1, 0. But for me to be able to swap the value at 0 to 2, 0, तो इधर है ही नहीं ना ये matrix में. For that matter, if I want to swap the value at index 1, 2 with the index 2, 1, 2, 1 वो index ही नहीं है इधर. See, with a square matrix, what was happening was, the good part was, for every ij, say for 0, 1, you had 1, 0. For 0, 2, you had 2, 0. For 1, 2, you had 2, 1. For every ij, you had the corresponding ji in the same array. That is why you could apply that method. But the problem over here is, with a general matrix, for every ij, I do not have the corresponding ji value available to me. That is why the method of swapping does not work with any matrix in general. It will work only with a square matrix. So please understand this. So whenever you are using the method of swapping, it will work only with a square matrix. Observe this. Now again, going back to the previous questions, we had 3 versions. See, this was pretty straightforward, that I need to generate the transpose of a square matrix. Now look at this. Right, so look at the second question. Write a program to generate the transpose of a given matrix using a method of swapping. What they've mentioned is that I'm supposed to use method of swapping. Now, if I'm supposed to use method of swapping, this is indirectly telling you that the program has to work for a square matrix only, because method of swapping does not work with any matrix in general. It will work with a square matrix only. See, there are only 2 possible methods of generating a transpose. One is the method of swapping, and the other is the one which I'm going to use, which is additional array. I'm going to create an extra array. Now understand, swapping method works only for a square matrix, whereas additional array method will work for any matrix in general, right? So look at the third question. It said, write a program to generate the transpose without using additional array. Now again, when they're telling me that you cannot use an extra array, then I'm left with only one method, which is swapping. This is again indirectly telling you that you are supposed to use only square matrices. So please remember, method of swapping works only for a square matrix, whereas the method which I'm going to discuss now, the additional array method, is going to work with any matrix in general. So whenever you get a matrix question, always read the question, pause for a couple of seconds and think, is it for a square matrix or is it for a general matrix? If it is for a square matrix, or swapping or both methods will work, but for general matrix, swapping method doesn't work, right? Okay, so my strategy I was going to be, please ध्यान से देखिए, I'm going to read a matrix of order m by n, which is say 2 by 3 in this case. इसका transpose के लिए I'll create another array B which will have this transpose. See, the value at 0 0 here goes to 0 0 here. The value at 0 1 here goes to 1 0 here. Value at 0 2 here goes to 2 0 here. All I can say is the value at index ij in A will get copied to index ji in B. So it's a very simple, straightforward program. I'm going to visit all the memory locations of this array. I'll pick up one value at a time. The value is at index ij. I'll copy it to index ji. That is what is going to be the strategy. Also, just in case if you've not observed this as yet, if this original matrix was of the order m by n, this is a matrix of order n by m. See, this original matrix A is of the order 2 by 3. So transpose is of the order 3 by 2. So always remember, for any matrix of order m by n, the transpose is always of the order n by m. I hope this is understood. Okay, so now what I'm going to do is observe. I'm going to have a matrix of order m by n A, and I'm going to get the transpose in order B. Now again, see, m comes back because this program again has to run for any matrix in general. So I've created an array. Now over here, m is the number of rows, n is the number of columns. I've read this, and then I've gone row column ij, row column ij. I've read this matrix. Now suppose over here you're going to give me a matrix of order 2 by 3. So m is 2 and n is 3. You're again passing this array A to this compute function. You've also passed the order as well. Now this compute function will accept this matrix of order 2 by 3 and generate its transpose, which obviously is going to be of the order 3 by 2. A very simple, straightforward function. Observe. Now what have we done over here? Observe. This compute function, I've created another array B. So A is going to be my original array and B is going to store the transpose. Now observe this. I'm going to go row column ij in A, and whatever is the value at ij in A, I'll copy it to ji in B. Now I'll execute this for a couple of steps. Now coming to this, from here, you've passed me the value m is 2 and n is 3. So m is 2 and n is 3. Now I'll start here. For I is equal to 0, m is 2. 0 less than 2 is 2, true. Come down. J is 0 and n is 3. 0 less than 3 is true. A of ij, I is 0 as of now, j is 0. It gets copied to B00. So A00 ka value kya tha? 6. It gets copied to B00. Then yahan se I go back, j plus plus becomes 1. So j is now 1. Come down. I0, j is 1. So I0, j is 1. 0, 1, j is 1. I0, j is 1. A01 ka value goes to B10. So A01 ka value goes to B10. Go back. J plus plus is now 2. 2 less than 3 is 2. Come down. I0, j is 2. Right? I0, j is 2. A02 goes to B20. This way. So this way my loop will continue and it will copy all the values that I have at index ij in A to index ji in B. That is how we'll get our output. Now, if I want to display my answer, obviously the matrix that I need to display is B. B has the transpose. Now B is a matrix of the order 3 by 2. Can I say B is a matrix of the order n by m? Number of rows is n and number of columns is m. So I'll go row column ij. But over here, number of rows is n and number of columns is m. So I'll display the answer transpose for I is equal to 0. Row column B of ij. Whichever matrix you are displaying, just have a look. Which is the variable giving you the row numbers? Which is the variable giving you the column numbers? Whichever variable gives you the row numbers, use it first. Whichever variable gives you the column number, use it next. And this is how you'll then get the output. So these are the two different versions of programs for transpose. There are two methods, method of swapping and additional matrix method. One last time, method of swapping works only for a square matrix. Method of swapping works for any matrix in general, including a square matrix, right? Now this brings us to the last program from this particular part of our syllabus. Write a program to multiply any two given matrices of order m by n and n by p. Matrices of order m by n and n by p. Now this particular program, again, a lot of times students say that this is difficult or they are not able to understand this. Now what I'm going to do is over here, obviously I'll give you the concept as well with whatever the code that we are writing, but at the same time, I'll also give you some little shortcuts. So when it comes to writing this program, you should be able to do it without thinking too much, right? Now, let us just brush up. Let us try and understand how matrix multiplication is done. Now, suppose if I have a matrix, this is 2, 5, 9, 3, 8, 6. I just picked up some random values. Suppose this is matrix A, which is of the order 3 by 2, right? So M and N, right? That is what it is. Now there is another matrix which I write, which is say 5, 8, 7, 9, 3, 6, whatever. So this is another matrix which is of the order 2 by 3. Now important, you cannot just multiply rows of any given matrix. You just cannot multiply any two given matrices. Important is, look at the order. Even if they don't say, you have to understand this. The number of columns in the first matrix has to be the same as the number of rows in the second matrix. Only then you can apply any two matrices. Only then you'll be able to apply those matrices. If you give me any two random matrices of any order, A by B and C by D, and you ask me to multiply them, no, I cannot do that. So over here, it is important whether they specify or not, you have to know this, that the number of columns in the first matrix has to be the same as the number of rows in the second matrix. Only then you'll be able to multiply these matrices. Now let us just try and recollect in mathematics what exactly happens when I multiply these two matrices. Let us try and understand. Now this is what it is. I have an array A of order 3 by 2 and I have another matrix B of order 2 by 3. Now how do we multiply the two matrices? Observe this. See, first and foremost, the result of this matrix would also be a matrix. Now observe this. What I know is that the result is going to be a third matrix, say C. Now how do we multiply? We always multiply the rows of the first matrix with the columns of the second matrix now. So what will happen is, this will be, the first term for this matrix would be 6 into 6, this multiplied by this, plus this multiplied by this, plus 2 multiplied by 13. I hope you'll know this, how to multiply a matrix. The rows of the first matrix will be multiplied by the columns of the second matrix. So that is, that information is very important for us. So we'll first take this, multiply with this, we'll take this, multiply with this, we'll take this, multiply with this, and so on, and I will get a resultant matrix, right? C. So whenever I multiply two given matrices, my resultant matrix is also a matrix, right? So that is the information. Now multiplication is little later. What I'll do is, I'll first write the main function. Now in the main function, what I'll do is, in the main function, I'll first read the two matrices. First one of the order m by n and second of the order n by p. Now how do we go about doing this? And then I'll come back to multiplication. Now in this main function, this main function will look a bit lengthy, but understand, I'm not doing anything new. So far in our programs, we were reading just one matrix. Over here, I'm required to read two matrices, right? Now observe this, how does this work? I've declared two matrices over here, A and B, and then a lot of variables over here. As of now, I'm not interested in this part. Okay, I'll ask you for the value of M. Suppose value of M that you have given me is say 3, value of N is 2, and P is 3. So my first matrix is going to be of the order 3 by 2, which is M by N, and my second matrix is going to be of the order 2 by 3, which is N by P. So this is M by N and N by P. So now I'm going to read the two matrices. Now I'll read my first matrix A. My first for loop starts over here. Row, column, ij. Now observe this. For I is equal to 0, I less than m. Rows of the first matrix, j is equal to 0, j less than n. Columns of the first matrix, a, I, j. How have we read this? Row column I, j karke, I've read my first matrix of order m by n. Now I'll repeat the similar code for reading a matrix of order n by p. I'll go row column I, j. So for the second matrix, number of rows, number of columns, row column I, j. Over here, I've read my second matrix, which is of the order n by p. So as of now, I have both the matrices with me. First one of the order m by n, second one of the order n by p. Now, what I now need to do is I just need to pass both these matrices to a third function, both these matrices to a function which will multiply these two and store the result in the third function. So I'm calling this compute function. See, so far, whenever we were calling compute function, we were passing it only one matrix, one array. But observe this. Now when I'm calling compute function, I'm passing it array A, I'm passing it array B. So I'm passing two arrays over here, A, B, and then I'm passing the order M, N, and P. So the first two values that I'm passing are arrays, and the rest three are normal integers, which is the number of rows and the number of columns. So obviously, when I'm passing these many values, samne my function has to accept it. Now observe this. What is my function accepting? I've just this slide looks a bit cramped, but just try and understand this. So over here, I've got the first array. What is this function accepting? First array. This is second array. So you have passed two arrays. So I've accepted two arrays. Apart from that, three variables you passed me, m, n, and p. So you've passed five things from over here. From over here, you have passed five things, and I've accepted those five things over here. Right? Don't bother about whatever these drawings are. I'll help you with the code. That is when we'll use them. Okay, so now I've come to this function. Now in this function, I'm going to write the matrix multiplication ka code. So over here, I've created another array called C. So that over here, my plan is whatever is matrix A, I'll multiply it with matrix B, and I'll store the result in matrix C. So C is going to be our final answer. So far, what have we done? In the main function, we've read the first matrix A of the order m by n. You've read the second matrix B, which is of the order n by p. And now we are going to multiply them and put the result in this matrix called C. Now, observe this. After this, actually speaking, now matrix multiplication ka code is just this much. That's it. That's it. Now what I'll do is I'll first try and give you the concept. Don't look at the code at all. Don't even think about it. Just understand the concept. I'll first give you the concept, and then I'll give you the little shortcut for multiplying the matrices. So just going out of this code, let us try and understand what exactly happens in mathematics when we are working with a matrix. Observe. If I want to multiply these two matrices that you see over here, now I'm talking of the drawings that you see. See, matrix multiplication ka basic funda is that you multiply the rows of the first matrix with the columns of the second matrix. Now, if I take this example, I'll multiply this row with this column. Kaise? So this will be 6 into 6 plus 2 into 13. It will give me this value. Then I'll multiply this first row with the second column. So this will be 6 into 2 plus 2 into 12. And this is how I'm going to get my values for the third matrix. So as of now, what I've understood is I want to multiply the rows of the first matrix with the second columns of the second matrix. That's it. Okay. Now, for implementing matrix multiplication, I'm going to use 3 for loops. Now, why am I going to use 3 for loops? Understand. Now, see, I want to multiply the rows of the first matrix with the columns of the second matrix. So if I want to multiply the rows of the first matrix, so I want someone to first give me this row, then someone to give me this row, then someone to give me this row. So I want someone to give me the rows of the first matrix, and that is what my first for loop will do. Understand my purpose of using 3 for loops. My first for loop will give me the rows of the first matrix. Now suppose this first for loop has given me this particular row. Now for me to be able to multiply this row, I want someone to give me the columns of the second matrix. पहले ये वाला column देगा, बाद में ये वाला column देगा, बाद में ये वाला column देगा. So I'll use my second for loop to generate the columns of the second matrix. First for loop will give me the rows of the first matrix. Second for loop will give me the columns of the second matrix. So that is why I need two for loops. Now observe this. Now over here, suppose somebody has given me this row and the loop has given me this column. Now I just cannot multiply any value with any value I like. No, the first value 6 has to be multiplied with 6 only. And then the value 2 has to be multiplied with 13 only. So this value has to be multiplied with this. This value has to be multiplied with this. So once I get the row and the column, then I want someone to ensure that the corresponding values are multiplied properly. And that is what my third for loop will do. So why do I need 3 for loops? Concept ke hisab se, please understand this. First for loop will give you the rows of the first matrix. Second for loop will give you the columns of the second matrix. And the third for loop will ensure that corresponding values are multiplied properly. I hope the purpose is understood. Obviously, I'm going to give you some little shortcut for writing this, but then this is what is the purpose. Okay, so now that we've understood the purpose of these 3 for loops, I'll first give you the shortcut of how to write these for loops, and then I'll talk about the actual execution. How exactly is the execution happening? Now, what I need to do is I need to multiply the rows of the first matrix with the columns of the second matrix. Kya karne ka? In this particular code where you had read this entire data, right? Isme se you find the for loop which is giving you the rows of the first matrix. So what I find is that in this on this slide, this is the for loop which gives me the rows of the first matrix. So what I'll do is I'll copy it as it is over here. I've copied exactly the same loop over here. I need to multiply it with the columns of the second matrix, which is the for loop which gives you the columns of the second matrix. This is the for loop which is giving you the columns of the second matrix. I've just copied this as it is. I've multiplied. I've picked up the for loop which gives me the rows of the first matrix. I've picked up the for loop which gives me the columns of the second matrix. Now what happens is I had 3 variables, m, n, and p. Now if you see, I've already used up m over here. I've already used up p over here. Whatever is the third variable, you just add over here. The third variable is n, and that is how I'll get my 3 for loops. So this is the shortcut. Exactly how they are working, I'm still to discuss that. So how do I write these 3 for loops? First, pick up that for loop which gives you the rows of the first matrix. Yahan se uthaya maine. Then pick up that for loop which gives you the columns of the second matrix. Then I've used here. I have only 3 variables, m, n, and p. M and p I have already used. Third for loop, mein whichever is the third variable remaining, you add that, and that is how you'll add these 3 for loops. Now, all you have to do is you've got to remember just one relation for matrix multiplication. C of ij is equal to C of ij plus A of ik plus B of kj. This will multiply the matrices for you. Now, how exactly is this happening? I'll try and execute this code as well for you. Now just observe this. Now just look at this. How does this code work? Now I'll execute with this example. See over here you have these 2 matrices A and B. A is of the order m by n, so which is 3 by 2, and B is of the order n by p. Now over here the values of m are m is 3, n is 2, and p is also 3. Now in this function I've created this array C which is going to store the final answer. For I is equal to 0, I less than m, 0 less than 3 is true. J is equal to 0, J less than P, P is 3, 0 less than 3 is true. Dono condition true hai, come down. C of ij is equal to 0. As of now, I is 0, J is 0. So I've initialized this memory to 0. See, in previous programs also, whenever we were writing sum is equal to sum plus, something like that. So for taking care of garbage values, we had initialized sum to 0. Over here, if you see the latter part of my code, I have written C of ij is equal to C of ij plus. In that case, I need to take care of garbage values. That is why I've initialized it to 0. Now, k is 0. What is the value of n? N is 2. 0 less than 2 is true. Come down. The new value of C of ij, I is 0, J is 0. As of now, if you see in these loops, all these variables as of now are 0, 0 only. The new value of C of ij is the existing value of C of ij, C is 0, 0, which is 0 plus. This is A of 0, 0. What is the value at A 0, 0? The value at A 0, 0 is 6 into B 0, 0. What is the value at B 0, 0? That value is also 6. So I've got this value. Yahan se, once this is done, I'll now go back. K plus plus is now 1. 1 less than 2 is true. Come down. Now coming down, what I find is I and J has not changed. The only value that has changed here is K. So I'm making that one little change over here. So in this expression, only K ka value has changed. So new value of C00 is the existing value of C00, which is this, plus A of 01. What is the value at A01? A01 is 2 multiplied by B10. What is the value at B10? You've got this, which is 30. Now when I go back, K plus plus is 2. 2 less than 2 is false. Condition fails. This loop has terminated. I've got my first term. Whatever is the value, 6 into 6 plus 2 into 13, whatever is the value, I've got that. Now once this is done, I'll go to J plus plus. J is equal to 2 now. Now J is equal to 2. 2 less than 3 is true. Now observe how are things changing. Okay. Now when I go here, see, I hasn't changed, right? Sorry, J plus plus, J would not be 0, J would be 1 because previous step J was 0. So J is now 1. 1 less than 3 is true. So C is C of IJ, I0, J is 1. Say C01. This has been initialized to 0. Now I'll start calculating the next value. For K is equal to 0, K less than N. N ka value kitna tha apne paas? This was 2. 0 less than 2 is true. Come down. Now if you see, I is 0, J is 1 here, and K is 0. So I is 0. So I'll put 0 wherever I see I. Okay. For J, I'll put 1 wherever I see J. And for K, I'll put 0 wherever I see K. Okay. Right. Now observe this. The new value of C01 is the existing value of C01, which is 0 plus A of 0, 0. Now A of 0, 0 is this value, which is 6. Plus into B of 01. B of 01 में क्या है? This is 2. ठीक है? Then go back. K plus plus is 1. 1 less than 2 is true. Come down. The only value that has changed is K. Baki everything is the same. The new value of C01 is the existing value of C01 plus A of 01. A of 01 is still 2 multiplied by B of 1, 1. B of 1, 1 is this. So again, it is multiplying the values properly. Then go back. K plus plus is 2. 2 less than 2 is false. My second term is ready. Then again, I'll change the value of J. I'll get this value. Once that is done, I'll go and change the value of I. When I change the value of I, my row changes. And that is how I'll keep calculating all these values. So this is how your matrix multiplication is going to take place. So this is giving me the rows of the first matrix. This is giving me the columns of the second matrix. And this is ensuring that I pick up the values properly. I need to pick up the values from the rows of the first matrix and multiply it with the columns of the second matrix. So this now completes matrix multiplication for us. And this also now completes two-dimensional arrays for us.